Welcome back. So today we're going to do a few things. We are going to talk about where you can get some data sets online, and then we're going to actually import a data set into Jupyter Notebooks, and we'll check it out, and then we'll find some correlations. So the first thing I actually want to talk about is where you can find data online to experiment with, and I think Kaggle is a very good resource. So I'm actually going to go ahead and insert a cell above here. So you can go to kaggle.com and you can find data sets there that you can download, check out. We'll be working with a data set from kaggle.com specifically on water potability. For those who aren't familiar, potability means the ability for water to be consumed safely. Okay, great. So let's actually start with importing the libraries that we're going to need. First, I'm going to import Pandas as PD. Just a reminder that we import Pandas because that allows us to use data frames. And we need a way in Jupyter Notebook to organize the data in a tabular form. That's what data frames do for us. So now that we've imported Pandas, I'm going to go ahead and import the data. So the water potability data that I got from Kaggle is in a CSV file. So I'm going to call my data frame df, and then I'm going to say pd.read CSV, and then the file name. Now I'm going to do this, and I'm just going to show you that it's going to error. It's not actually going to work. Great. Oh, whoops, I forgot to run the cell above. Let's try it now. Great. So it's not going to work, and this is the error I wanted to get. And as you can see here below, file not found error. Errors are, they're very colorful and they can be daunting to look at, but what you really want to do is look for information in the error that helps you identify how to solve it. Here it's a file not found error, so no such file or directory. And the reason I'm showing this to you is because this CSV file it's on my desktop right now. However, it's not in the folder that this Jupyter Notebook session has access to. So I'm going to pause here. I'm going to bring that file into the session environment, and then I'll just show you that it runs. At this point, I've moved the file into a folder that is accessible by my Jupyter Notebooks. And I'm going to go ahead and run this again. Perfect. So it ran. Now I'm going to explore the data. So I can actually just use df, and this works. I see that I have 3276 rows and 10 columns. Great. And then if I look at this, I can see pH, hardness, solids, chloramines, sulfate, conductivity, organic carbon, trihalomethanes, turbidity, and then finally potability. So this is the water potability data, right? So already looking at this, I'm starting to formulate what would my predictors here be and what would my response variable be. So basically, what would my x's be and what would my y be? And I see that potability is drinkability. That seems like a strong y, right? That's like, okay, this is what I want to be able to predict. And I see here that the values range between 0 and 1. So then that's starting to look like a logistic regression. And then if we look at these predictors, what we would want to know is which of these should be included and which are not important. That's more downstream work, but these are the kinds of things as a data analyst, as a data scientist, you want to start thinking about when you're looking at the data frame that you've imported. I see another thing here, which is that there are some null values, some NaNs. So doing further analysis will mean looking into what we want to do about that. Great. So there are a couple of things we can do, just some commands that you can use that are helpful. Let me actually show you something. So find rows and columns. To do that, you can do df.shape. I think it has parentheses. I don't, okay, no, it does not have parentheses. So let's just do it this way. Perfect. So you can use df.shape. So this tells me the number of rows, 3,276, and the number of columns, 10. Look here, same thing. And again, you could have named this anything. Like I could have named this water df, right? And that would have been perfectly fine too. I would just have needed to refer to the variable as water df afterward. Okay, awesome. The last thing that we want to do here is let's just start looking at some possible correlations. So to find correlations, we can do df.core and then add parentheses and then command enter to run. I'm on a Mac, by the way. So great, we get this correlation table. Now the correlation between a variable and itself will be 1, right? It's going to be perfectly correlated with itself. So you can see that here, pH, pH, hardness, hardness. Anyway, we're definitely going to continue using this example and trying to find a model that actually does work, that does give us better than baseline accuracy. But this is a short exercise. And just to remind you, Kaggle is where you can go to find interesting data sets you can download and play around with in your own environment. For data frames, we need to import Pandas. And then you can use this command, pd.read_csv, to import your CSV file. What's important is that your CSV file is reachable by Jupyter Notebook if that's what you're using. So you need to make sure you're moving it into the correct folder. And then you can just do df. I should show you one thing, that I can use this command df.head to return 5 rows back to me. That's the default. And as you can see here, the index starts at 0. However, if I put a value in here like 10, then the default is overridden and I'll get back 10 rows, right? Similarly, this is starting from the top. You can start from the bottom of the data frame. You could do df.tail, and this will give you the final 5 rows. And you can do the same thing here. If you want the final, 9 rows, you could get those back as well. We'll talk more about this. We'll touch upon this many, many times, but that's all for today. All right, until next time.